Hello friends, welcome to engineering tutorial. In today's video we are going to discuss an important concept which is related to subject of control systems, which is about the transfer function of a system. Okay, so let's start. So when I say transfer function, okay, in control system it is called as transfer function, whereas in other areas it is called as the gain of the system. Okay, so let us say we have a system, okay, represented by a block. Okay, we give it an input and we get an output. This is the system. We get an output. Now this input, it is essentially a time domain signal, a signal whose magnitude varies with time. Let us represent it as, let's say, RT. So as the input is dependent on time, so the output will also be time varying. It will also be a time varying signal. Let it be CT. Okay. Now let the gain of the system, let us represent it as TF, means because of transfer function I am using the short form TF as a function of T. Now an important thing to take care here is that all the things involved here are in time domain. We have not used any other approach like S domain or Z domain or Fourier transform, omega domain, frequency domain, nothing. It's simply in time domain. So the gain of the system, this transfer function, is simply the ratio between output and input. We know gain is the ratio between the output and the input, which is equal to CT by RT. Now, in control systems, in the subject of control systems, the time domain approach is not used to represent the transfer function of the system. Okay, here the Laplace transform approach is used. Okay, the Laplace transform approach is used. Now what is Laplace transform? The Laplace transform is a mathematical tool which transforms a time domain signal into frequency domain. Okay, it transforms a time domain signal into frequency domain, actually the S domain, which can be represented in terms of frequency. Okay, so what is the Laplace transform? We'll discuss that. It's a very vast field which requires a lot of lectures to cover, but here just as a brief introduction I will give you an introduction to Laplace transform. The Laplace transform of a time domain signal, let's say ft, it is given as integration from limit 0 to infinity the time domain signal ft into e to the power st dt. Okay, this is the Laplace transform of the signal ft, and it is represented as f as a function of s. Here it is small f, here it is capital F, and this s is given as j omega, where j is the imaginary iota and omega is the angular frequency. Okay, for now you just understand this much. This is the Laplace transform. So in control systems, this Laplace transform is used to represent the input, the output and the transfer function of the system. Okay, so here the transfer function would be represented in S domain, the input will be represented in S domain, capital RS, and the output will also be represented in S domain, CS. So the transfer function is given as CS by RS with the condition that all initial conditions are set to 0. Okay, all initial conditions are set to 0, means the time from which, let's say it is 0, the time from which the system output input is being considered, all the values are set to 0, they have no previous value. Okay, that's what it means. So the transfer function is the ratio between the output and the input, the Laplace transform of the output and the input with all the initial conditions being set to 0. Okay.